Hello, am I audible? Hello.
Yes.
Okay, thank you. Someone is raising a hand. Do you have any query? Good evening everyone. I am Priya Takwal. I am doing PhD at IIT Kharagpur under the supervision of Professor Sudeep Mishra, and today we will discuss some topics of week 4, and after that we will discuss the assignment question of the same week. So yeah. Last week we were discussing about the applications of wireless sensor network, so I'll continue with this only. So one of the main application of wireless sensor networks is target tracking. So basically, in case of your surveillance systems, target tracking can be used in order to detect the suspicious activities that are taking place. So in order to track a particular target, wireless sensor networks can be used. So basically this target tracking can be of 3 types. Wait, someone is trying to join. So target tracking is of 3 types. First one is your push based formulation, second one is your pole based formulation, and third one is your guided formulation. So in case of your push based formulation, what happened is The wireless sensor nodes which are deployed in an area, they will sense the environment, and if they find some activity is taking place or someone is trying to enter into a particular area, they will send the notification, they will send the data to the sync node periodically, and based upon the data which they are sending, it is detected whether someone has entered into the particular area or not. The second type of target tracking is pole-based target tracking. So in case of your pole-based target tracking, the data is sent to the sync node only when the wireless sensor nodes which are deployed are poled. So whenever your sync node will ask for the data, then only those sensor nodes are going to transmit the data. So till that time they are going to store the sense data at the storage unit only. Now the third type of target tracking is guided formulation. So in case of your guided formulation, the nodes which are deployed in a particular area, they are going to detect the further or future possibilities of movement of particular target. So the nodes which are going to predict that movement are called your beacon nodes. So some kind of models, machine learning models are deployed over these nodes, and based upon the movement of your target, their speed, their acceleration or their direction, the future place of your target is detected, and on the basis of that prediction, your tracker is going to follow the path and going to detect your target. Now, since if we put all the nodes in a particular area on, or all the nodes are participating in exchanging the data, if there is total cooperation, then the lifetime of the nodes will be less, right? So in order to prevent that, it is necessary that there is some coordination between the nodes, and after some interval of time, some nodes are at sleep mode and some are at awake mode. Okay, so for that there should be a cooperation between your nodes. So basically, first of all, in order to track the target, there should be some node cooperation. After that, based on the nodes which are active, they are going to detect the presence of a target, and the beacon nodes which are present, they are going to predict the possible movement of the target, and the tracker is going to follow that path only. And since all the nodes are not active at a particular time, due to which energy management is done, and if a particular node which are active, whose energy goes down, then we are going to shut down that node, and other nodes which are at sleep mode are going to detect the movement of the target. So this phase is your recovery phase. So basically these are the 6 phases. First is your node cooperation should be there, then the position computation should be there, then we are going to predict the movement of the target, then energy management should be there, and after that recovery, and then target detection on the basis of all those phases. Now the next application of wireless sensor networks is in your agriculture field. So in case of your agriculture field also, you can utilize wireless sensor networks in order to detect the if there is some intruder which are trying to get into your agriculture field, or if you want to detect whether your crops are getting proper amount of nutrients, they are getting proper amount of moisture or not. So for all those purposes we can use wireless sensor networks in your agriculture domain. So for this you can use various types of sensors. You can use camera, and you can use your PIR sensors, your ultrasonic sensors, in order to detect all those things. Okay, so in this figure, as you can see that this is the agriculture field, and we have deployed some sensors over the boundary of your agriculture field, and if some intruder wants to enter into your agriculture field, the sensors are going to detect, and further on the basis of this data is sent to the sync node, and further on the basis of this data some computation is done, and for the farmer will get alerts over their cell phone whether there is some intruder into your field or not. Now there is one more wait. Now there is one prototype which was developed with the help of your wireless sensor network for your agriculture domain. The name of the prototype is AID. So this prototype is using two types of sensors in order to detect whether there is some intruder which are getting into your fields or not. So this prototype is using PIR sensor and ultrasonic sensor. So when an intruder wants to enter into your field through the boundary, your PIR sensor is going to detect, and the ultrasonic sensor is going to sense the distance of the object at the position which your object is located. So the layer diagram of this AID prototype is this. Basically layer 1 consists of your physical devices, that is your sensors. First one is your passive this PIR sensor, and second one is your ultrasonic sensor. Then in the second layer processing is done by the microcontroller. So some processing is done in order to find whether there is some intruder or not, and then wireless routing is performed in the third layer in order to send the data to your sync node first, and further to the messages to your farmer. Okay, so these messages or SMS are sent with the help of your layer 4, which is going to provide interface to your end users. Now the other possibility is you can use your humidity sensor in order to detect whether your crops are getting proper amount of moisture or not. So in order to detect the health of your crops, you can use a humidity sensor whether they are getting proper amount of water. If they are not getting proper amount of water, then you can actuate the sprinkler, which can give water to your crops after a regular interval of time. So this is one this is other possibility where you can use wireless sensor networks in field of your agriculture. Now you can also use cameras in case of your agriculture, because using only scalar sensors will not provide you the accurate results. So better will be to use your scalar sensors with in integration with your multimedia sensor, that is your camera sensors. So basically the integration of both your scalar sensor and your multimedia sensors will provide you better results. So the coverage will be better and the connectivity of various sensors will be better. So the final results or the output which is got by your farmer or end users will be better if they are going to use your multimedia sensor in integration with your scalar sensor. So this work is proposed by Mishra et al. In the paper, where they have used this multimedia sensors in integration with your scalar sensor in order to improve the coverage and connectivity. Now the next application is your nano networks. So so in case of your nano networks also, you can use wireless sensors. So the nano devices has the component of sizes in order of nanometers only. So the sensor actuators all are size of in order of your nanometers only, and the AM communication for your nano networks lies in the range of 0.1 to 10 terahertz. Now the communication between your nano sensors is in the form of your molecules, and molecules are used as information, and these informations are packed into vesicles, and the gap junctions work as mediator between the cells and vesicles in order to transmit the information. After that, this thing is firstly performed by your Japan lab, at entity, and this communication at your nano sensors is your electromagnetic based communication. Now the third type of application, the fourth application of your wireless sensor networks is your underwater acoustic sensor networks. So you can also utilize your wireless sensor networks under your under sea or your ocean. So you can place various sensors in order to check the wildlife habitat, that how the health of the animals is there, or or how they are living there. Okay, so basically three types of localization algorithms are there. First one is your three-dimensional localization. Second one is your high-speed AU based silent localization. Third one is your opportunistic localization. However, in case of your underwater acoustic sensor networks, the placement of your sensors is difficult, and after that the routing of data is difficult. Actually the exchange of messages get affected by the waves which take place in your seas or oceans. So these waves are responsible for the loss of data, for the change of route of your data. So all these factors are there in case of your underwater. So yeah, so in a layered shallow ocean region, the inclusion of the effect of internal solitons on the performance of network is important, as I have already told you that, and based on the various observation, it is proved that non-linear internal waves, that is your solitons, are one of the major scatter of your underwater sound. So if a sensor nodes are deployed in such an environment, the internode communication is affected due to the interaction of wireless acoustic signals with these solitons. So basically these solitons are responsible which are creating any kind of interference and the exchange of messages. Now the oceanic forces and their impacts. So the performance analysis of UWSN renders meaningful insight with the inclusion of mobility model which represent realistic oceanic scenarios. The existing works on the performance analysis of your underwater wireless sensor networks lacks the consideration of major dominating forces which offer impetuous node mobility. Okay, so basically the works which are there in existing literature, they don't consider these oceanic forces which are responsible for the node mobility. So in order to consider these forces, the paper is proposed by Mandal, which consider this mobility of your sensors due to these oceanic forces. Now self-organizing virtual architecture. So basically for these sensors there is a need in order to these sensor needs to be self-organized. So there is one approach, that is your tic-tac-toe architecture, which is responsible for the self-organization of your wireless sensor nodes which are placed in your underwater. Now There are two concepts which are related to your wireless sensor networks. One is your coverage and second one is your connectivity. So coverage is related to the area of interest which is covered. So basically, in case of your coverage, it is checked whether the area where sensors are deployed, it is properly covered or not. So every point of that area is sensed by your sensors or not. So this is called your coverage. And in case of your connectivity, if all the nodes in your networks are connected or not, this is checked. Okay, so basically for your sensor coverage, it studies that how to place your sensors, that where exactly to place your sensor and what should be the density of those sensors. Okay, so if we are going to deploy less number of sensors, then there are chances that your area is not fully covered. There might be some areas or points which are not sensed by your sensors, or which are not detected by your sensors. So this is the one major problem that we need to consider while deploying your sensors. So we can use two different types of sensor. One is your static sensor and second one is your mobile sensor. So in case of your static sensor, the main problem is where to deploy the sensor and how many number of sensors we need to deploy. Okay, however, in case of your mobile sensor, the topology is important, because in case of your mobile sensor, the sensors are moving regularly, right? So the topology is changing. So in case of your mobile sensor, it is necessary that if a particular sensor moves from its place, then also the particular area is covered only. So there is a relationship between your transmission range and sensing range. Okay, so sensing range is the area till what point your sensor is going to sense your region. However, your transmission range is the area or the point till what it can transmit the data. So basically it can be shown with the help of circular region. So a particular circular region till what your sensor can sense the area is your sensing range. However, that point till what your sensor can transmit the data is your transmission range. So these two circles are basically concentric, and your sensing range or sensing area is smaller as compared to your transmission range. So if your transmission range is greater than equal to 2 times your sensing range, then it means coverage implies connectivity. So this is the formula which is proposed by researcher, and they have proved it mathematically that if your transmission range is greater than equal to 2 times your sensing range, then it implies that coverage implies connectivity. So basically the main problem is your coverage. So we need to understand that how to place the sensor so that whole area is covered properly. So coverage. So it determines how well the sensing field is monitored or tracked by your sensors. So to determine with respect to application specific performance criteria. So in case of your static sensor, the main coverage problem is where to deploy the sensors or how to activate them. And in case of your mobile sensor, it is necessary that how to plan the trajectory of your mobile sensors. So in what manner your mobile sensor should move so that each and every area of your particular region is covered. Now these two cases are collectively termed as your coverage problem in your wireless sensor networks. Now the two types of reporting of an event. One is event driven and second one is on demand. So in your wireless sensor networks, events can be of two types or data exchange can be of two types. If some event occurs, then your sensor are going to transmit the data. On the other hand, in case of your on demand, whenever data is requested by your controller, then only the sensor are going to send the data. So in case of your event driven are used basically in case of your whenever there is some hazard, for example forest fire monitoring, or if some machine is corrupted. In that case event driven reporting of data is done. However, in case of your inventory control system, on demand delivery of data is done. So the main objective is to use minimum number of sensors and maximize the network lifetime. Now what is this network lifetime? So different researchers have proposed different definition for your network lifetime. So some has defined network lifetime is that if the lifetime of one particular sensor node. So if any of the sensor node is going to die, then it means that is the particular amount of network lifetime. On the other hand, some researchers have defined your network lifetime as the lifetime of all the sensors, and some others have defined as some number of, for example, p number of your sensors lifetime as your network lifetime. Now the coverage algorithm which is proposed are either centralized, distributed and localized. So first one is your distributed. So in case of your distributed coverage algorithm, nodes compute their position by communicating with their neighbor nodes only. However, in case of your centralized coverage algorithm, the data is collected, the data from all the sensor nodes is collected at the central point, and further on the basis of that data a global map is created, and based on that global map it is decided, the position of various nodes are decided, and it is decided whether the area is covered properly or not. And the third type is localized. So in case of your localized algorithms are a special type of distributed algorithms where only a subset of nodes are active. So only a subset of nodes are responsible for sensing, communication and computation. So basically here the position are calculated by communicating with neighbors only. However, only a particular subset of nodes are active. Now, sensor deployments method. So sensors are either deployed randomly, you can place your sensors anywhere in that particular region, or some deterministic approach can be followed also based on your sensing and communication ranges. Now the objective of the problem is that to maximize the lifetime and to use minimum number of sensors. Now your problems are classified into three categories. These coverage problems are classified into three categories. First one is your area coverage, second one is your point coverage, third one is your barrier coverage. Now in case of your area coverage, we need to provide the deployment of sensors in an energy efficient manner such that whole of your area is properly covered or sensed by your sensors which are deployed. And on the other hand, in case of your point coverage, there are some random points in your particular area. So in case of your point coverage, it is determined whether those points are covered or not. And third is your barrier coverage. So in case of barrier coverage, a particular barrier between two objects or two places is covered. So if that barrier is covered with the help of only single sensor, at least one sensor, then it is your one barrier coverage. And if it is covered by at least two sensors, then it is two barrier coverage. And if it is covered by at least k sensors, then it is k barrier coverage. Now, okay. So in order to determine that whether all the points or all the area is covered properly or not, crossings are used. So basically crossings are the intersection point between the disk boundaries or between the monitor space boundaries and the disk boundaries. So as I have told you that your sensing range is in the form of circle. So this is the disk here, that circle or that point till which your sensor is going to sense the data is in the form of disk, right? So the crossings are the intersection of two disks. So one disk for one sensor and second disk for second sensor. So crossings are the intersections. Right. So a continuous region N is covered if there exist crossings in that area and each crossing is covered. For example, in this figure, as you can see that these three crossings are not covered, right? So at these points there are chances that there are some points or there are some regions which are not covered. However, the fourth crossing is properly covered, right? It is covered by the third sensor. So these areas are properly covered. Now a crossing is covered if it is in the interior region of at least one node's coverage disk. So this is what I have told, that if the crossings are covered at least by one sensor node, then the region is properly covered, that particular region is properly covered. Now the optimality conditions, that how to place your sensors so that all your points are properly covered and the minimum number of sensors should be used. So in case of your static sensors, consider that this A and B are the static sensor and we have placed these two sensors there. Now we need to place the third sensor. So the optimality conditions for placing the third sensor will be that this RO should be equal to your QO. So we need to place your third sensor in such a manner that your RO should be equal to your QO, and the distance between your A and the center of this A and the center of this C, the distance should be your under root RS. And however, if your sensors are mobile, then all these 3 points, that is your RO should be equal to QO, and that should be further equal to your OP. Now this is what I have told you. So the distance between this X and Z should be equal to your under root of RS, and for every point actually, this XY, XZ and YZ should be equal to your under root of RS. Now OGDC is the algorithm which is used in order to place your sensors in a particular region, so that minimum number of sensors should be used, and your whole area should be covered properly. So the working of OGDC is given here. So first of all, we need to select a particular starting node. So that particular starting nodes, any node present in that particular area voluntarily participates with the probability of P. So for a particular time, that is called your back of time, it waits, and if it doesn't hear anything from its neighbor, then it declares itself as the starting node, and further it declares its position and preferred direction, so in which direction it wants to communicate. So after that, the other node which is present at a particular distance from that node in that particular direction, the preferred direction by your starting node, it receives the message, and further it will announce its direction and further communicate with other node. Okay, so in this way, all the nodes which are present in a particular region are going to interact with each other, and they are going to cover the complete region, and they are going to send these messages till the complete region is covered. Now the stationary, so if you are going to use stationary or static sensor nodes, then what happened is, for example, if particular nodes get failed, okay, or get corrupted, then there are chances that your network get disconnected. For example, in this figure, if your these red dots, so consider these nodes as your failure nodes. So these are not working. So if these are not working, then it is dividing your network into 3 different networks. So in order to prevent this from happening, what we need is, we need some mobile sensor nodes. So if we are using mobile sensor nodes, then some sensor nodes will move from here and are going to cover this area and are going to cover this area. So to resolve the problem which is created by your static sensor, we need some mobile sensor. So first of all, the advantages of your static sensor is it is very easy to deploy. Then nodes can be placed in an optimized distance, which reduce the number of nodes, and further it is very easy to maintain their topologies. However, on the other hand, there are disadvantages of using static sensor, which I have discussed, that the placement of static sensors can also result in your in results in disconnecting your complete network. So the solution for this is to utilize the mobile sensors. Now the mobile wireless sensor network. So mobile wireless sensor networks are your self-configure, self-heal, self-optimize and self-protect. Okay, and the components of your mobile wireless sensors are mobile sensor nodes, which are going to sense the environment, mobile sync. So this sync is responsible for collecting the data from your mobile sensors, and data mules. So data mules are the devices which are responsible for collecting data from your sensor nodes and transferring that data to your mobile sync. Now the application areas of your mobile wireless sensor networks. So first one is your terrestrial mobile wireless sensor. So in case of your in order to monitor your wildlife, for surveillance, for object tracking, you can use mobile wireless sensor networks. On the other hand, you can also use for your aerial surveillance, mobile data gathering. You can use mobile wireless sensor, and for underwater also, for monitoring the marine life, for detecting the water quality of your oceans and your seas, you can use your wireless sensor networks. Now the possible entities as mobile nodes in your daily life. So what are the different entities that can participate in your mobile wireless sensor network? So first one is your human. So humans are wearing various types of sensors, so they can also act as one of the entity. So mobility in that case is difficult to monitor, and the cell phones which humans are using are responsible for gathering the information. Then the vehicles, so various kinds of sensors are deployed over your vehicle. The vehicles can also act as one of the possible entity. Third type of entities can be your mobile robot. So these are only three, others are also there. Now next topic is your human centric sensing. So the basic idea behind your human centric sensing is that humans are going to carry various types of devices or various kinds of sensors which are going to sense the environment or sense the body of the human, the vitals of human, and various sensors are embedded within the devices which are carried by human, and these devices are responsible for your sensory readings. So basically your the humans perform three distinct roles. First one is your sensing targets. So in case of your sensing targets, humans themselves are sensed. So basically the vitals of humans are sensed by various types of sensors. For example, your temperature sensor, ECG, these types of sensors. Second is your sensor operators. So in this case, humans are going to use the sensors or devices in order to monitor the surroundings or in order to sense the environment. Third is your data source. So in case of your data source, they are not going to actually use sensors. However, humans are going to disseminate or collect the data without using the sensors, with the help by sensing the environment, and after that updating that on your social media sites. Now the challenges in case of your human-centric sensing are so the energy of devices, because continuously we are going to sense the surroundings. So one of the major disadvantages, the lifetime of those devices will be less, or these devices are utilizing large amount of energy. Second one is participant selection. So who are the people who are going to participate in this, or who are not? And third is your privacy of users. So in case of your human centric sensing, we are utilizing the data of or we are sensing the personal data of humans, right? So this is one of the major issue in case of your human sensing, human centric sensing. Now UAV networks. So UAV network basically is the networks which is created by your flying objects. So two types of topologies can be used in case of your UAV, that is your mesh and star topology. So it is a flexible deployment and management of new services can be done with the help of your SDN in case of your UAV networks. Routing protocol should be adaptive in nature. In case of your UAV network, since these devices are mobile, these devices are moving continuously, so routing protocols which are used by your UAV should be adaptive. This UAV network should contribute towards the greening of networks. So basically the energy which is consumed by your UAV should be less. Then they should be multi-tasking networks. After that, large coverage area. So UAV network should be able to cover large area, and they should be easily reconfigurable in case of if any device is if any device get fail, then there should be other device which is going to cover the area which is covered by that particular device. So the complete network should be easily reconfigurable. Now the challenges of UAV networks. So there are frequent changes in the network topology because the devices are mobile. The relative position of UAV may change. Then there can be malfunctioning of UAV devices. Intermittent link nature is there due to the movement of devices. Then the lack of suitable routing algorithm, this is one of the major problem. Then after that, the disadvantages of UAV networks are there are frequent link breakages, they are prone to malfunction, huge power requirements are there, they are very complex as they are mobile, and since there are no suitable routing algorithms, so it's very difficult to manage UAV networks. Then they are physically prone to environmental effects such as wind, rain. Now the topologies which are used by your UAV networks. First one is your star topology. So in case of your star topology, the UAV devices are various UAV devices are going to interact with your base station or control station which is present at the ground. And in case of your multi-star configuration of your star topology, various UAV devices are going to interact with one particular UAV device, and that particular UAV device is further connected to your ground station. So basically different stars are formed at the different stars are formed by your UAV, and these out of these stars, that particular node is further connected to your ground station. Second type of topology is your mesh topology. So in case of your flat mesh topology, the one particular mesh configuration of your UAV devices, one of the nodes of particular that mesh topology is going to connect it with your ground. However, in case of your hierarchical mesh topology, the various meshes are interconnected with each other, and they further are connected to the ground control system. Now, flying ad hoc networks. So, what is the difference between your flying ad hoc networks and UAV networks? Anyone? Because till now we are talking about UAV network. So the network which is formed by your UAV devices is called your UAV network, right? So flying object network. So here also there is a network between your flying objects. So what is the difference between your flying ad hoc network and UAV network? Why we are using two different terms? Anyone? Okay. So this UAV network is more general term. Actually, this flying ad hoc network or FANET is a subset of your UAV network. So in case of your UAV network, infrastructure may be required or may not be required in order to exchange messages. However, in case of your flying ad hoc network, no infrastructure is required. Okay, so basically intermittent links are there. So whenever two different aerial devices come closer to each other, or if they exchange some messages with each other, this FANET is formed. However, in case of you in your UAV network, if two devices come across each other, or they are going to exchange messages, then this is also UAV network. But sometimes there are chances that predefined infrastructure is set and then exchange of messages take place. However, in case of your FANET, no such kind of predefined infrastructure is set. So in case of your FANET, there are intermittent links between your aerial devices or your flying objects. So network formation using your UAV, which ensure longer range, clearer line of sight propagation and environment resilient communication. So and after that, there are various types of communication that can take place in case of your FANETs. So first one is your interplane communication. So if the communication between the devices which are present in the single plane, which are present in the two different planes, then it is called your interplane communication. So basically, for example, if communication take place between your UAV 2B and UAV 3A, then it is your interplane communication. Second is your intraplane. Intraplane communication means if the communication between the devices of same plane take place. For example, your UAV 3A and UAV 3B, then it is your intraplane. Then ground station communication. So if the communication between your these UAV devices and ground station take place, then it is your ground station communication. Then fourth one is your ground sensor communication, FANET ground sensor communication. So if these your FANET devices, that is your UAV devices, are going to interact with your sensors which are deployed over the ground, then it is your FANET ground sensor communication. And last one is your FANET-VANET communication. So if the communication between your flying objects and your vehicular network take place, then it is your FANET-VANET communication. Now next topic is your machine to machine communication. So in case of your machine to machine communication, the communication between your various machines take place. For example, in this figure, if there is a crash between two cars, then the sensors which are deployed over these cars are going to sense this thing, and further they are going to send the data through your remote server, and the hospitals or the doctors or the ambulance are going to fetch that data, and on the basis of that data they are going to perform some tasks, right? So basically the communication between different machines which are taking place are called your machine to machine communication. Now the properties of your machine to machine communication. So large number of nodes or devices are communicating with each other. In case of your machine to machine communication, it should be low cost, energy efficient, small traffic per machine should be there, large quantity of collective data should be there, and machine to machine communication free from human intervention. So basically this is the main point. So in case of your machine to machine communication, there should not be any kind of human intervention. However, in case of your IoT networks, human intervention can be there. So basically this M2M is a subset of your IoT networks. Now the service architecture of your machine to machine communication. So basically there are three layers. First one is your machine to machine area network, where various physical devices are there. Then your access network. So with the help of this, these physical devices are going to communicate with your core network or with each other also. So in case of your core network, it is basically divided into four categories. First one is your device, user, application and access. So this device layer is responsible for device profile management, device and machine to machine area network management and device searching. However, your user unit is responsible for user profile management, authentication of various devices or various users which are present in the network, and charging of these devices. third is your application. So application unit is responsible for the data collection, data control, service management and connection management. And last is your access. So access is responsible for your app management, app searching and web portal. So don't get confused if someone asks that that app management is performed by which of the component of your core network, then it should be access, not application. Application is responsible for data collection, data control, service management and connection management. So app based things are done by your access unit. Now if the communication between two machines is your non-IP based, then this is the architecture. So basically these are the layers of two different devices which are communicating with each other. So if it is non-IP based architecture, then the layers, the application layer is seamless. The intermediate application layer is seamless between the two devices. However, your transport layer, network layer and physical layers are different. On the other hand, for IP based M2M architecture, all the layers are seamless for two different devices. Now the questions. Okay, so first question is, which of the following M2M node types have no IP support? First one is your low end sensor nodes, second one is your mid end sensor nodes, third one is your high end sensor nodes, fourth one is your all of the above.
A.
A. Okay, so what is low end sensor nodes?
Sensor nodes with less functionality.
Okay, and mid sensor nodes?
They have moderate level of functionality.
Okay, so I'll define. So basically, in case of your low end sensor nodes, these are cheap and have low capabilities. These are static, energy efficient and simple. The deployment of low end sensor nodes has high density in order to increase the network lifetime and its servability. These are resource constrained and have no IP support. Basic functionalities of low end sensor nodes are data aggregation, auto configuration and power saving. These are generally used for your environment monitoring application. However, on the other hand, your mid end sensor nodes are more expensive as compared to your low end sensor nodes. They can be mobile, however fewer constraints with respect to complexity and energy efficiency is there in case of your mid-end sensor nodes. Additional functionalities, so basically the functionalities which are provided by your low-end sensor nodes are there, and apart from that, functionalities such as your localization, quality of service, TCP/IP support, power control and traffic control intelligence, these are also there in case of your mid-end sensor nodes. These are typically used for home network, SCM, supply chain management, asset management and industrial automation. And your high-end sensor nodes, so we don't need to deploy them very densely. They are able to handle the multimedia data also. So basically the high amount of large packet sizes they are able to handle with quality of service requirement. Mobility is there. The example of high-end sensor nodes are your smartphones, and these are generally applied to ITS and military or biomedical applications. So the correct option for this is your low-end sensor node. So low-end sensor nodes have no IP support. Second question is, which of the following is true for wireless sensor networks if transmission range is greater than equal to 2 times the sensing range? Options are only coverage, only connectivity, coverage implies connectivity, connectivity implies coverage.
C.
C. Coverage implies connectivity. Why? Okay, what is coverage and what is connectivity?
Coverage is how much the sensors can detect from the area,
Okay.
and connectivity is how these different nodes actually, whether they can communicate with each other.
So coverage range is less or connectivity range of a particular sensor is less?
The range at which they can transmit is usually higher.
No. I'm asking whether the point till which a sensor can sense the data is less, or the connectivity, or the till what point it can send the data is less.
The sensing range is lesser.
Okay. Yeah. So correct option for this is coverage implies connectivity. Next question is, which of the following structure is usually used in guided formulation of target tracking in sensor networks? First one is phase, second one is tree, third is cluster, fourth one is all of the above. Anyone?
C.
No, it's phase. So a phase structure is used in case of your guided formulation. Next is, which of the following is not a characteristics of your UAV networks? Options are intermittent link nature, static network topology, third one is your dynamic relative position of your UAVs, fourth one is your none of the above.
Static network topology.
Static network topology. Right. So in case of your UAV networks, the devices are mobile, they are continuously changing their positions, and further their topology is also changing. So they have dynamic network topology, due to which the routing in case of your UAV network is also difficult to achieve. Next question is, which of the following is a challenge in human-centric sensing? Options are device lifetime, participant selection, privacy of user, all of the above.
All of the above.
Right. So in case of your human-centric sensing, all these are the challenges, because in case of your human-centric sensing, all the devices are active or sensing the environment, due to which their lifetime get affected. After that, which particular set of participants are going to perform the task of sensing, the selection of that is difficult, and privacy of user is also one of the challenge, because in case of human centric sensing we are using the personal data, uh, so this is also the challenge. Next question is, which of the following component in M2M service platform take care of app management and app searching? Options are device, user, application, access.
Access.
Right. So access is responsible for your app management and app searching. Next question is, in distributed coverage algorithm, nodes compute their position by communicating with blank. Options are central node, sync node, neighbors only, none of the above. Anyone?
Neighbors.
Right. Yeah. So in case of your distributed coverage algorithms, the node compute their position by communicating with neighbors only. Next question is, in multi-star UAV network, blank nodes from each group connects to the ground station. Option are 0, 1, more than 1, all.
One.
Right. Next question is, electromagnetic communication in nano networks take place in blank frequency band. Options are gigahertz, terahertz, nanometer, all of the above.
Terahertz.
Terahertz, right. Can you please tell me the range also? No?
0.1210.
Right. So 0.1 terahertz to 10 terahertz. Next question is, which of the following is not a property of mobile ad hoc network? Options are self collaborate, self heal, self protect, self optimize.
Collaborate.
Right, self collaborate is not a property of mobile ad hoc networks. Next question is, which of the following layer seamlessly integrate IP network with M2M area network in a non-IP based M2M network? Options are application layer, transport layer, network layer, physical layer. Anyone?
Application layer.
Right. So in case of your non-IP based M2M network, application layer seamlessly integrates. However, in case of your IP based M2M network, all the layers seamlessly integrate the two IP networks. Next question is, while maintaining sensing coverage in sensor networks, a crossing is covered if it is in interior region of blank one node coverage disk, at most only at least more than.
At least.
Right, at least. Next question is, which of the following UAV network topology is decentralized? Options are star, infrastructure mesh, ad hoc mesh, none of the above.
Ad hoc mesh.
Right. So this star and infrastructure mesh is the topology of your UAV network. Next is can a node failure result in partition of networks in case of your mobile wireless sensor networks? Options are yes, no, not applicable.
No.
Right. So in case of your mobile wireless sensor networks, if a particular node fails, then it will not result in the partition of network, because some other nodes will take the place of that particular node. Next question is, which of the following is true for high-end sensor nodes in M2M node types? Options are high density deployment, second one is your unable to handle multimedia data, third is your mobility is essential, and fourth is your all of the above. Anyone? High-end sensor nodes. We have discussed these in first question.
C.
C. Mobility is essential. Right. Next question is, which of the following UAV topology is self-configuring? Mesh, star, both mesh and star, grid.
Both mesh and star.
How your star topology is self-configuring? See, in case of your star topology, if a central node get affected, then whole your network will get affected, right? However, in case of your mesh topology, each node is interconnected with other node, right? So if particular link will get affected, or if particular node is affected, then the other nodes can interconnect or communicate with each other through other links. So your mesh topology is self-configuring, however, the star topology is not. Next question is, in general, target tracking problem consists of wireless sensor networks whose nodes are strategically or randomly deployed across the sensor field. Is this statement true or false? Is this statement true? See, in case
Yes.
of this the correct option for this is yes, because in case of your target tracking problem, we deploy sensors either deterministically or either randomly, right? So this statement is true. Next question is, in ad hoc FANETs, which of the following setup can be considered as ground network? Options are stationary wireless sensor network, control stations, VANETs, all of the above. Anyone? In ad hoc FANET, which of the following setup can be considered as ground network?
All of
Stationary.
these.
Right. So, in case of your FANETs, these flying objects can communicate with these all three kinds of your ground networks. Next question is, which of the following component in M2M monitors the status of devices and M2M area networks and controls them based on their status? Options are M2M user platform, M2M device platform, M2M service platform, M2M access platform. So status of devices is monitored by which of the following? M2M user platform, device platform, service platform, or access platform? Anyone? Correct option for this is M2M device platform. Next question is, in the guided target tracking problem formulation, a tracker is added to the problem. The tracker follows the trajectory defined by beacon nodes to interpret the target. Which of the following objective best define this target algorithm? So first option is to fuse data about the target. Second option is to use the least amount of communication to reach the target. Third is to reach the target in the shortest possible time. And fourth one is to increase the network lifetime. Anyone?
C.
What was the option? Series to reach the target in the shortest possible time. Question was yeah. So correct option for this question is C. Next question is in WMSN application, which of the following deployment can provide better sensing and prolong network lifetime? Options are scalar sensor nodes, camera sensor nodes, both scalar and camera sensor nodes, and vector sensor nodes. In case of your wireless multimedia sensor networks, which of the following deployments provide better sensing and prolong network lifetime?
C.
C. Both sensor, scalar and camera sensor nodes, right? So for better sensing, camera nodes are required. However, these nodes generate large packets and require more energy, so the integration of both scalar and your camera sensor nodes are required. Next question is, in which of the following algorithm only a subset of nodes in WASL participates in sensing, communication and computation? Options are localized, distributed, centralized, all of these. Only a subset.
Localized.
Right, localized. So in case of your localized, this is done by only a subset of devices. So in case of your distributed, the location is calculated or computed with the help by communicating with the neighbors. However, in case of your centralized, a global map is created, and in case of your localized, a particular subset of nodes participates in sensing, communication and computation. Next question is, in gateway selection algorithm in FANETS, each UAV requires the information of all UAVs within blank hops. Options are 1, 2, more than 1, cannot be specific. Anyone? Okay. So in case of your FENETs, the flying objects communicate with your ground station with the help of gateways. Okay. So how to select that particular gateway? Which device will act as gateway? So that gateway should be more reliable and at least at most 2 hops away from each of the device. So the correct option for this is 2. So all the UAV devices or all the flying objects should be within 2 hops from that particular device. Next question is, a crossing is covered if it is in the blank region of at least one node's coverage disk. Options are exterior, interior, either exterior or interior. Last is boundary.
Interior.
Right, interior. Next question is, there are several major challenges related to target tracking applications. Which of the following is not among those challenges? Options are target recovery, node non-cooperation, future position estimation, energy management. On the second slides, we have discussed the various steps or the challenges which are there in target tracking application. So correct option for this is non-cooperation. Next question is, which of the following components in M2M manages inquiry? Options are M2M user platform, M2M device platform, M2M service platform, M2M access platform. Anyone? Correct option for this is M2M user platform. Next question is, which of the following is not regarded as one of the major skaters of underwater sound in underwater acoustic sensor networks? Options are non-linear internal waves, solitons, linear internal waves, none of these.
C.
C. Linear internal waves. Right. Next question is in OGDC algorithm, a node blank if its coverage area is completely covered. Options are wakes up, start listening, sleeps, back off.
Sleep.
Right, sleeps. So basically, if the region which is covered, that particular node, it is covered by other sensor nodes, then that node will sleep. Next question is which of the following elements of target tracking algorithm can perform data fusion? Options are active node, inactive node, beacon node, sync node. Data fusion. Correct option for this is sync node. So basically active nodes means the nodes which are sensing, communicating. Inactive, they are not participating in any of these. Beacon nodes are those nodes where model is deployed and they are going to perform the prediction of the position of the target. However, your sync node is responsible for the fusion of your data. Next question is which of the following components of your mobile wireless sensor networks move in order to collect the data from sensor nodes? Options are mobile sensor node, data mule, mobile sync, both data mule and mobile sync.
Both data mule and mobile sync.
Right, both data mule and mobile sync will move in order to collect the data from your sensor node. So these were the questions of this week. Now if you have any yeah, I want to make an announcement. So on 7th of next month there will be a live session where Mishra sir will come live, and if you have any query or if you want to interact with him, you can also join. YouTube link will be shared with you. And second announcement that I want to make is please don't message me personally on my Gmail or on LinkedIn. So this is the only platform where we can interact, or you can also ask question on discussion forum. So okay, if you have any question or any queries regarding the topic which we have discussed today. So apart from these lectures and the lectures which is provided by NPTEL, you also have to follow books. Because questions will also come from books. So the links of the books are given on the site already, so you can follow. One is your introduction to Internet of Things, and the name of the other book is Introduction to IIoT and Industry 4.0. So you can follow these two books in order to get more idea. So will the recording of this meeting be made available? Yeah, I'll upload this on YouTube. You can check there. Any other question?
What is FENNET?
Okay, what is FENET? So, is it clear that what is vehicular ad hoc networks or what is ad hoc networks? Is it clear to you?
Yeah, this is clear.
Okay, so basically, if the ad hoc networks moves to air, that is FENET. So the ad hoc network which between your flying object is your FENET. Now, why two different terms are used? Why UAV networks is different from your FENETs? So, in case of your FENETs, the connections which are formed between different flying objects are intermittent, right? However, in case of your this UAV networks, it can be infrastructure based and infrastructure less also. And in case of your FENETs, it is always infrastructure less. It is intermittent. Clear?
Yeah.
Okay.
What is data mule?
Data mule is any device which is moving in the network, and that device is going to collect the data from your sensor nodes and further transmit that data to your sync node. So these can be sensors also, and these can be other devices. Yeah, are there any applications of FENETs nowadays? Yeah, obviously you can use FENETs for surveillance, for your military purposes also. Your drones can be deployed over the borders to detect any activities that are taking place in your borders. In your agriculture also, FENETs can be used. During COVID time, drones are used in order to sanitize the areas, or in order to provide different products to the user. So these are the various applications of FENETs. Any other question?
Ma'am, what is inquiry in M2M?
What is
Inquiry in M2M.
inquiry in M2M?
Yes, ma'am.
Okay, that thing I need to check. I'll let you know in next lecture.
Okay, ma'am.
Um, Any other question?
What is the need of ad hoc networks?
What is the need of ad hoc networks that you provide? So basically, if your network is static, if sometimes, for example, in case of underwater where the network is not consistent, or in case of your borders where we cannot access the sensors which are deployed there, so in those areas, or the areas where it is difficult to deploy the infrastructure, there is a need that the sensors or devices which we have deployed can interact with each other without any human interference, right? So in that cases, there is a need that the connection should be made seamlessly between the devices, and whenever required, the connection get disconnected. So in those cases, ad hoc networks are required.
Hi Riya, this is Ganesh. I have a question for you regarding SDN, Software Defined Network.
Yeah.
Is this software defined network,
Yeah.
is this the one that is used in the ad hoc network, or is it something different?
uh, SDN is basic. Yeah, that can be used in your ad hoc network. Basically, in case of your someone is presenting screen, I guess. Who's Yeah, in case of your SDN, your data plane and the control plane is kept separately in order to make the routing easily. Okay. Uh, so it can be used in case of your ad hoc networks, and it is your choice whether to use or not. So basically, the use of SDN will make the routing process easier. So we are going to discuss about SDN in detail in the later lectures.
Okay, thanks.
Yeah. Surya Prakash Reddy, you are presenting your screen. Surya Prakash Reddy.